Hello and welcome to Lecture 2. In the first lecture, we saw how the poorest in the poorest regions of the world are engaged in casual labor and how that ties them into a poverty trap. Now, a natural question to ask is how common are these arrangements? What type of jobs do the poor do? And in order to answer that question in a systematic way and to facilitate research into labor and poverty, I've put together with Hamad Al-Sayed, Andreas Murra, and many others, a new database which will soon become public. I can zoom in here. This is our homepage. The database is being put together with the IZA for the G2LM LEAK program and covers all middle income and low income countries. We cover about 90% of the population in those countries. And we harmonize all the available censuses and DHS surveys. The way we link the censuses and the DHS surveys, and the main innovation of this database, is that we build comparable measures of wealth. Now, both censuses and DHS contain information on household assets. They are not necessarily the same, but they can be used to build indices, such as a principal component, and for the countries for which we have both sources of data, we can check how similar the results are. And having shown that they are quite similar, we can then merge the two sources for countries for which we only have one. So this will allow us to build up macro statistics from individual level data. And this will allow us to document changes in the organization of labor across the process of development. So the first thing that we see as a sanity check is what we know very well, which is that over the course of development, we observe a structural change from agriculture to manufacturing and services. This is the share of people in all these countries engaged in agriculture. You see, it falls from about 60% to 10%, and this is in manufacturing and services from 40% to nearly 90%. Always bear in mind that the data set stops at the highest of the middle income countries, so everything here is up to GDP in PPP of about 10 in logs USD per capita. Now, this is what we know. Is less known that structural change comes together with organizational change. That is, the way labor is organized changes over the course of development. We move from the majority of people being self-employed, so we say there's about 90% in the lowest income countries, to the opposite, the majority of people being in salaried jobs. Now, a lot of the theme of these lectures is the difference that these shifts makes. And this is an important shift because, as I will elaborate further in the rest of the lectures, when everybody is self-employed, the same person or family, so the maximum size of the organization is a family, have to deal with every aspect of the business. So say that they are engaged in farming, they have to deal with the technical aspects, with the commercial aspects, with anything that involves. So the same person has to be an engineer, a trader, an accountant, and so on. When organizations grow, people can specialize in what they can do best. An interesting pattern emerges when we split this data by wealth quintiles. In these graphs, the blue are the poorest, the lowest quintile, and the red are the richest. We see that the first people to get wage jobs when these become available are the richest quintiles. So you can see here that in the poorest countries in the world, the poor are almost entirely engaged in self-employment, whereas the richest people in the same countries have some wage jobs. You can see from here the poorest have no salaried employment whatsoever, and the richest have about 40%. And notice that is monotonic in wealth because the light red is the second richest, the gray is the middle, the light blue is the second poorest, and the dark blue is the poorest. So we see that the transformation starts from the top, and the share of wage jobs increases smoothly for the upper classes, whereas it's got kind of an S shape for the lowest classes. So for the lowest levels of GDP, for a wide range, say from here to here, the poor remain self-employed. Lecture 3 will be mostly about this and why it needs to change for an economy to grow. Now, the interesting point is that this pattern is not a derivation of structural change. That is, it is not the case that we have more wage jobs because we have more employment in manufacturing and services. The change from self-employment to wage jobs occurs in every sector, including agriculture. In these graphs, we have the shares in the two types of contracts on the first y-axis, and we have the ratio of self-employed, of wage workers to self-employed on the second x-axis. And we see that this, if you follow the dashed line, that ratio increases in every sector. Interestingly, as we saw earlier, it is very flat for the bottom levels of GDP, then it gains momentum and it keeps growing. In lecture 3, we will make some conjectures about the determinants of this shape, and we will link that to the evolution of organizations and the link to growth. Today, I'm going to look at a possible side effect of this transformation. Add to this, and that is that as men shift into salaried labor, something else happens, which is that the labor force participation of women goes down. Now, one possible interpretation of this fact is that salaried labor, salaried jobs, normally take place out of the household. So there is a transformation from self-employment activities, either in agriculture or small trade, that employ the entire family, to a division in labor in and outside the home. Now, whether this split by gender makes sense depends on the returns to women's labor outside the home. And that will be the topic of the next paper. But this is a recent paper which I wrote with my colleague Nava Ashraf at the LSE and two PhD students, Virginia Mini, who's at the LSE, and Victor Quintos Martinez, who is currently at MIT doing their PhDs. So the starting point for this paper is the observation that women labor force participation is low. The idea that engaging women in the labor force is a sure way to increase national income has an old pedigree. Arthur Lewis, in one of my favorite papers on economic development, it's called Economic Development with Unlimited Supplies of Labor, makes the case for engaging women outside the home very clearly. Despite this, we know that in every country in the world, we are very far from gender parity in the allocation of work inside and outside the home. There is a lot of advocacy, if not policy effort, to address this on equity grounds. However, there could be also an efficiency argument that can be made, like Arthur Lewis did back in 1954, and more recently in a great paper by Chantal Sier, Chad Jones, Eric Hurst, and Pete Leno, where they estimate a structural model of growth with wedges to participation by ethnicity that differ by ethnicity and gender, and they show how a large fraction of the growth in the United States over the last 40 years was actually due to a reduction in barriers for women to participate in the labor force. So, can equality actually increase national income? If we go at the micro level, the answer fundamentally depends on whether the returns to women's talent are higher outside relative to work inside the home. Unfortunately, these are unobservable, the returns are unobservable, and they can produce observationally equivalent levels of female labor force participation. That is, if returns to women's talent are higher outside the home, only the women with the highest talent will work outside. If they're higher inside, it would be the other way around, but the fraction of women in the labor force will be the same. However, the composition matters a great deal to assess the answer to the question whether increasing labor force participation can improve efficiency. So when returns are higher outside the home, that is where the talent of women can be profitably used in jobs outside the home, we will have positive selection. Take the distribution of ability to be a standard normal, or as normal as I can draw it. We have positive selection if only women past a certain threshold can go to work. So the lower is this threshold, the lower the mean ability of women in the workforce. So when returns for work outside the home are larger than returns for work inside, then we'll have positive selection. In this case, increasing labor force participation by women can increase equity and efficiency. Contrary to this, if the selection is negative, that is, if it is women below a certain threshold that work outside the home, save for necessity, there is no improvement in efficiency that can be had by bringing an increase in labor force participation. In this paper, we use observable differences in earnings combined with variation in labor force participation to infer unobservable differences in selection and hence the relative returns. We begin by combining personnel data from a large multinational enterprise, which hires about 100,000 employees over 100 countries, and we combine those with female labor force participation data over 4 cohorts. The idea is that the correlation between the wage gap and female labor force participation under certain conditions is informative of the sign of selection. Barbara Petrongolo and Claudio Olivetti had a paper where they made this point back in 2008, and the point is very simple to illustrate by taking the distribution of women's ability. Let me see if I can draw something that vaguely resembles a normal distribution. Okay, roughly. And then, if, so say that this is ability on the horizontal axis, essentially the point is that if selection is positive, that is, if only women past this threshold are observed in the workforce, when labor force participation increases, threshold moves back, the number of women in the workforce increases, and if wages are reflective of marginal product and ability, the wage will go down. So the simple yet very powerful intuition behind this model is that it generates a negative correlation between the wage of women and the labor force participation. Because as the labor force participation increases, as we saw in the graph above, the ability of women gets lower. So this point here corresponds to a low labor force participation, a high threshold, and this point here, so this is low and this is high. So this is the low point and that's the high point, and a low wage will be higher than at the high point. So that's what we're going to test. It's not a perfect test, it only holds under some assumptions, but I will make precise under which assumption it holds, and I will provide evidence in favor of those. Now, going back to the slides, that's our first step. Then our second step, once we establish the sign of the correlation, is to estimate structurally the firm pay policy parameters. That will allow us to back out the ability distribution and evaluate policy counterfactuals, including the possibility of eliminating all difference in gender norms. Finally, we will use data from the Orbis dataset, which is balance sheet data for reasonably large firms. The definition is not very precise, but we can use this data to assess whether the estimates that we derive from that one company are informative for other firms in the economy. Of course, the policy parameters are specific to the company, but to the extent that the selection of women in the company and the selection of men in the company is similar to the selection in the other firms in the economy, then our estimated ability gap will be informative of the ability gap in the economy as a whole. So these are white-collar employees. We only look at the local employees because we're interested in knowing the ability of the women that self-selected when the labor market was in such a state. So we, of course, could link to the labor markets of the expats, but the selection of expats is not the same, and it will become clear why this is important in a little bit. It's a homogeneous workforce. They all must have a college degree, and they all have the same college degree. It's either a degree in business or a degree in engineering. Typical jobs involve sale, product development, marketing, and in general, managerial activities. And we have 4 years of data. It might be worth looking at the map, maybe not, to understand how the relationship between labor force participation and wages can tell us about the relative returns of women's ability in and outside the home. It's easier to start with a simple ROI model where there are two sectors, the home sector and the market sector, and people differ in skills as well as taste for the two sectors. We denote the skill for the market sector by A and the skill for the home sector by N, and we assume they're independently distributed as normal 0, 1. The wage policy is such that the wage in the market sector is a constant alpha 1 plus a part which depends on ability, which is reflecting of the fact that people are paid somewhat their marginal product, so ability gets a weight, beta 1. While the value of staying at home has the same form, but has an additional component, which is the preferences, the taste for staying at home. So an individual will go to work outside the home if the payoff of doing so, if Y1 is larger than Y0. If you simplify the equation, it comes to this difference, which is the difference in fixed pay plus the difference in the part that depends on the returns, and that has to be larger than the taste for being at home. We say the selection is positive if beta 1 is larger than beta 0. Now visually, in the AN space, you can depict this choice as a line. This is the line that makes people indifferent between being in the home sector or in the market sector, this line here. And this first panel A represents the case of positive selection. In this case, you see that when female labor force participation increases, so there are more people to the left of this line, the line shifts forward, you see the ability decreases and hence the wage goes down. Vice versa, if selection is negative, it is the people with low ability that participate in the market, that work in the market. And so when female labor force participation increases, the line shifts outward and the average ability increases. You see it from here to here, and the wage goes up. So we know that if selection is positive, the wage decreases when labor force participation increases. Okay? So we know this way, this direction of causality is what we just showed. Now, if the converse is true, that is, if it is the case that when LFP increases, the wage decreases, then we can, the sign of the correlation between female labor force participation and the wage gap will allow us to sign selection. In other words, in the previous graph, we show that if selection is positive, then the change in wage as a function of the change in labor force participation is negative, because as selection is positive and you increase labor force participation, less able women come into the labor force. But what we observe in the data is this, and we want to infer something about the sign of selection. So the model will tell us the conditions under which the opposite link, that is the opposite direction of causality, tells us the sign of selection. if we solve for the difference in the pay, if employed, between women and men, this can be written up as the sum of two components. The first is the difference in fixed pay that doesn't depend on ability, and then is the expression that captures the differences in ability, which is made of two terms. The first is the difference in selection, which is this piece here, and this is decreasing in labor force participation. And then this component here is a sign, has the same sign as the difference in returns. Okay? So remember that we are interested in establishing when the difference in the correlation between labor force participation and the wage gap tells us the sign of this expression here. We need three identifying assumptions. The first is that this term does not depend on labor force participation. Or to be more precise, we need something less stringent. We need that the correlation between this term and labor force participation is no opposite and larger than the correlation that we're interested in. So that essentially, intuitively, that rules out things such as women being more discriminated in Sweden than in India. We need the second assumption that we need is that the returns that are used to identify, the returns to market work and homework are the same across the units that are used to identify them. Okay? Well, because we are using some variation in labor force participation to identify the relationship. If the relationship is not the same in different countries, say, then of course we can't identify anything. Note that this is probably the main advantage of using the data from the M&E rather than the data, the macro data at the country level on the wage gap. Because when we use the data from the M&E, the policy, the pay policy is the same. And so the returns are the same in all the different units. Empirically, we will test the validity of this assumption by using different sources of variation, that is, variation across country and variation within country across cohorts. The third assumption that we need is that the difference in selection that we observe in the firm reflects selection in the labor force at all levels of labor force participation. This assumption rules out that women are more discriminated at the point of hiring in Sweden than in India. It also reflects the fact that the selection for men and women is the same. So the same level of ability, men and women are attracted by the firm. Okay? So the selection into the firm mirrors selection into the labor force. If men and women weakly prefer our firms to other firms, so what this rules out is that high ability individuals of one gender are not observed in the firm because they do not apply. So, for instance, it is we need to assume that there is no job, no local job that attracts high ability men more than high ability women. We will present some evidence on that. And then the second assumption that we need is that the firm hiring policy does not mute the variation in labor force participation. This rules out that the firm selection policies, for instance, affirmative action, undo or reverse the gender ratio in labor force participation. So, of course, we can test whether the female to male ratio in the firm mirrors that in the country. And when we do that, we see that there is indeed a very positive correlation, which is almost one-to-one and does not differ according to the levels of labor force participation. So to begin with, we estimate the relationship between the gender wage gap and labor force participation non-parametrically, and we see that the data is consistent with positive selection. That is, as the labor force participation increases, the wage gap goes down. Actually, the wage gap is positive, meaning that women earn more than men, all the way to labor force participation equal ratio, that is the ratio of female to male labor force participation, smaller than 6.6. When you go further than 0.6, the estimated wage gap becomes negative. So again, under the three assumptions that we made precise earlier, the fact that this correlation is negative suggests that the selection into the labor force is positive. That is, only the most able women work outside the home. This is the regression equivalent of the graph that you just saw. So we estimate on the full sample of employees, we estimate the effect of the female dummy. So this is the wage gap when labor force participation is 0, and that's the sign of the selection. There's a couple of things which is useful to note in this table. The different columns, 1, 2, 3, 4, control for different things. So the first one has no controls, the second has tenure squared, and the function that the worker is using. And then column 3 and 4 use different sources of variation. Column 3 uses the cross-country variation and has cohort fixed effects, whereas column 4 uses the within-country variation with country fixed effect and uses the variation across cohorts. Now, the reason why this comparison is interesting is that a key identifying assumption is that the returns are the same across the units that we're using to identify them. And you can see here that it doesn't matter whether we use the cross-country or the cross-cohort variation, the selection, the sign of the selection always comes positive. Our third identifying assumption requires that the selection into the company is the same for men and women. That is, it rules out things such as the existence of better jobs for one gender and not the other. So one way of interpreting the results that we've seen so far is that in countries where female labor force participation is low, there are better jobs for men, and so the top ability men go and do those jobs, whereas the top ability women come into the multinational. And so what we're measuring is not a different selection into the labor force, but rather a different pattern of selection into our firm. To rule that out, we can study where the difference in ability between men and women come from. That is, if it comes from the top of the ability distribution, and meaning that the most able women are more able than the most able men, then we would have to worry. If it comes from the bottom, that is from a different threshold, that is the interpretation that we want. So we are interpreting this difference take the ability distribution. Our interpretation of the finding is that there is a threshold for men and a threshold for women, and the threshold for women is to the left, so that the least able women, this one here, is more able than the least able man here. But we could think the data is observationally equivalent to another story, which tells you that there is actually two thresholds for men, and that there are some jobs in the local economy which are preferable to working for this multinational, so that the men at the top, go and work in those jobs. So we have two thresholds for men, and the men that we observe in the firm are not the best. They're kind of an intermediate level. So if that were the case, we would not be able to conclude that what we are observing is due to the green threshold being higher than the blue threshold, because there could be a second blue threshold here for men, which is below the green threshold for women. Now, to rule that out, or to test whether that's the case, we can compare the top men to the top women and the bottom men to the bottom women. And this is what this regression does here. This is estimating the difference between men and women at different quantiles. And you see that the entire difference comes from the top quantiles. From the bottom quantiles. That is, it is the women who are least paid who are paid more than the men, rather than the top. So all the difference comes from the bottom quantiles. And to quantify the cost of misallocation, we need to know the counterfactual productivity of women outside the labor force. And this is unobservable by definition. What we do is that we use the variation in pay and labor force participation across countries and cohorts to estimate the ROI model that I set up earlier on. That will allow us to back out the distribution of men's and women's talent in the workforce, as well as the level of misallocation. So these are our basic assumptions. Individuals differ on two dimensions. The ability, AI, determines productivity in work outside the home, and we assume it's distributed normal for every gender, cohort, and country. Then we have preferences and homemaking skills and that determine their utility at home. And again, we assume that this is normally distributed 0-1 for every gender, cohort, and country. Now, as is standard in the misallocation literature, but also supported by the results of positive selection, we assume that the beta zero, that is the return for ability in the home, is 0. The firm wage policy is log linear in individual ability, and we allow for the wage policy to vary at the gender, tenure, age cohort, and country level. So to be precise, we assume, the only thing we need to assume is that the shape, the functional form of the wage policy is the same in all countries, but the parameters can vary, not just at the country level, but also for people of different age, different gender, and different tenure in the firm. The beta is the returns to ability, which varies by tenure to allow for on-the-job learning to be correlated with ability AI. The value of staying at home as an equal functional form. There is a constant term and then an individual specific term that depends on their preferences. Okay? We interpret the gap in the value of staying at home between men and women as the cost of social norms. Equivalently, we could interpret this as a tax that women pay when entering the labor force. Now we have one parameter too many to identify, so we normalize the variance of the returns to skill in the market and of the preferences for staying at home, the sum of those to one. So then we have three moments, we have three parameters, so we can solve exactly. The important thing here and the distinctive feature of having the personnel data for one company is that we can observe variance, or rather variation, in the pay of people of the same gender, tenure, age, and country. And we can use that variation to identify differences in ability. Being employed. So here is a recap of the parameters that we can identify. We have 4 parameters in the payoff for working outside the home and working inside the home. We can identify 3 by normalizing, as I already mentioned, the sum of the square of those two to 1. So the unconditional average value of staying at home as an empirical target, the labor force participation. The unconditional average log wage has as an empirical target the average observed log wage controlling for selection. And finally, the returns to ability in the firm as an empirical target have the variance of the observed log wage controlling for selection. We restrict the sample to country cohort gender tenure cells that have a minimum of 30 observations because we need the variation, and that leaves us with 87,000 employees and 58 countries. We take the residuals of log pay on the year because we have 5 years of data, and on the function because, say, people in the finance division are paid more than people in HR. Then we use the labor force participation for gender G, cohort A and country C, and we take the data from the moment when cohort A entered the market. The data is from the World Bank. The idea is that the selection is captured by when you first enter the labor market. Once we've calibrated our parameters, we can retrieve ability from the wage equation. Okay? Note that the ability that we estimate also captures peer effects and other correlates of ability and productivity if there are any. Now this is our first result. The women's mean ability is always higher than the men. So in this graph, the women are, and all following graphs, women are in dark blue and men are in orange. And you see that the calibrated ability for different levels of the female to male labor force participation, the gap is almost one standard deviation at low levels, and then it shrinks, but it never gets to zero. This is the structural equivalent of the quantile regressions that we saw earlier. The effect comes entirely from the countries where the labor force participation is lower, and importantly, is due to a right shift of the entire distribution, except for the right tail, that is, the top men and women are the same ability in every country. What's missing here in low labor force participation countries is this tail of low ability men. We do a number of validation tests to validate a measure of ability. And so first we correlate it with other measures of performance that we don't use to estimate ability. These are subjective appraisals by managers, future wage growth, and measures of sales productivity that we have for a subset of the countries. I think my favorite one is the correlation with wage growth, whereby we estimate ability for the people who join the firm in the first year of our data, and then we correlate that estimated ability with the growth of the wage over the next 4 years, and we find a strong correlation. We can use differences in group composition to test whether the estimated differences in ability are due to peer effects or the value of diversity per se, that is, having more women around. An interesting implication of these findings is that because the average ability for women is higher everywhere, then if we correct for that difference, the estimated wage gaps are even larger than we think, that was estimated without the control for ability. Now we have the other parameters of interest is the difference between the stay-home payoff between men and women. That also decreases in labor force participation, and interestingly, it correlates with gender norms in the country. We can see the correlation here. This is, we've taken the main variables that capture gender norms in the World Value Survey, which are available for the majority of our countries. And you can see that if you put these variables and correlate them with our estimated gap in the value of staying at home, they're strongly correlated in the right direction. So for instance, a commonly used measure is the answer to the question, preschool child suffers if the mother goes to work, and lower numbers indicate more conservative norms, and then you see that countries where the norms are more conservative have a bigger gap in home payoffs. So an important question is whether these differences could be explained by difference in preferences rather than differences in barriers. Okay, so in our model, we assume that the underlying distribution of ability and preferences for staying at home is the same for men and women, so that differences in labor force participation are due to the cost of social norms. Alternatively, we could ask how different the population mean of the value of staying at home in the preference function would have to be to justify the current observed gap in labor force participation. we can derive this with our data, and we can show that it would have to be orders of magnitude larger than any other estimates of gender differences in preferences. Of course, we can't compare it to the difference in preferences from staying at home because that's not been measured anywhere, but we can compare it to preferences such as risk aversion, confidence, and the like that have been measured across countries in a recent survey by Armin Falk and co-authors. And we see that the differences in preferences from home between men and women would have to be several order of magnitudes larger. Now, to quantify the cost of gender norms, we consider a counterfactual where we equate the parameters of the value of staying at home under three different wage policies in the firm. In other words, when we do counterfactuals, we have to assume something about what the firm does. That is how they respond to these different counterfactuals. The simplest and probably more misleading assumption is to assume that the firm does not respond, so they keep the parameters fixed despite the fact that the environment has changed. The more flexible approach is that we allow the firm to re-maximize, so to choose the alpha 1 and beta 1 that maximize their productivity with the new assumption that the value of staying at home is the same for men and women. Now, what fits the data best is a model that's in the middle. That is where we keep the assumption of constant employment and constant wage bill, passing the unconstrained optimum, but we put a restriction on the inequality that can be created between men and women in the firm. So equating the cost of staying at home for men and women will result in different patterns of selection into the labor force, and in particular we will see some exits and some entry. The average ability of the entrants will always be higher than the average ability of the exiters, and this is plotted here by country. The bottom line is that after we readjust the sorting into the labor force and into the firm, in most countries, all countries but these two, there would be a productivity gain. And because we're keeping the wage bill fixed, this productivity gain effectively corresponds to a profit gain. The average is 32%, and for countries where labor force participation is very low, it actually exceeds 50%. And this is coming entirely from the fact that you can substitute women who are more productive, allowing them to join the labor force, and replace men who are less productive, and that is what determines the increase in productivity. That is, if we go back to our drawing of the selection, what you're doing is, this is the distribution of ability for women, and this is for men. To start with, say that the threshold for men is there, and the threshold for women is here. As you allow the payoff from staying at home to be the same, this threshold moves to the same point as this one, meaning that all the inframarginal women that join are better than the men who leave. And so that's where the increase in productivity comes from. So obviously productivity is an important outcome, but not the only one that we care about. We also care about the effect of this equalization of gender norms on the welfare of men and women. The effect on welfare tends to be positive for high ability type, but also interestingly for high N types, where N, remember, is the preference for staying at home. And the reason for that is that as a consequence of the equalization, high men with high N can now stay at home instead of going to work if that's their preferred option. Another fundamental parameter that determines the effect on welfare is the extent to which the parameters of the pay policy are constrained to be equal for men and women. The more constrained the parameters are, the more losers there are, because the firm loses an instrument to tailor the pay to the individual ability. We can also use our model to assess the effect of equalizing pay parameters between men and women and of changing labor regulation. Now, both measures, equal pay and labor regulation, limit the firm's ability to reward talent and end up with the unintended effect of hurting the most talented. So this is the summary of the welfare effect of eliminating gender norms. In short, high ability women gain, low ability men lose, but also men with high preferences for staying at home gain because they can now act on those preferences. Our final question is to try and assess the extent to which our estimates are informative for other firms in the economy. We saw that selection into the firm mirrors selection into the labor force. So we want to know whether the ability gap that we estimate is actually captures misallocation in other firms in the same countries. We use the balance sheet data from the Orbis dataset on manufacturing firms in the same countries where a firm operates, and there are 800,000 firms operating in 150 three-digit sectors in 48 countries. So the first thing that we do is that we take our ability gap estimated at the country level and we correlate, we fit it in a production function at the firm level, and this is column 1 and 2. In column 1, we take the standard production function, that's log sales on the left-hand side, regressed on log employment and capital and GDP of the country. And we see that our estimated gap negatively correlates with productivity. In the second column, we also control for labor force participation because the gap is correlated with labor force participation, so that might have a direct effect. But we find that, if anything, the effect of the ability gap is stronger. The third column identifies the effect within country. That is, we control for country fixed effect, and then we see whether the estimated ability gap with our firm is more informative for firms that belong to the same three-digit sector. And we find that that indeed is the case. Of course, the effect is smaller because it's much narrower, but what this tells you is that we're not picking up some country-specific effects. More is the analysis of the productivity, the effect on the mean of productivity and the dispersion of productivity at the three-digit SIC level, especially the dispersion. So this is not using firm level data, this is using sector level data. And you see that the ability gap that we estimate from our firm correlates with the mean productivity in that sector, and most importantly correlates with the dispersion of productivity, which is a measure of misallocation. So overall, accounting for selection and signing selection can shed light on our understanding of gender gaps and policies in labor markets. First implication of our findings is that the wage gaps are actually larger than we thought, because the difference in ability between men and women, we're not comparing like we like. So if we adjust the wage gap for white collars, the estimated wage gap for white collar workers, the unadjusted gender gap is always smaller than the adjusted gender gap. And for some countries, this difference is quite substantive, like Bangladesh has, because it has a low labor force participation. Once we take into account the average ability of women relative to men, we see that actually the adjusted gender gap is much, about 30 percentage points bigger than we previously thought. The other counterintuitive result from the selection argument is that women are more likely to suffer from labor regulation in countries where female labor force participation is low, because in those countries women are of higher ability and labor force participation and pay regulation prevents firms from rewarding ability, and in doing so it hurts the higher ability workers. And the final implication for firm pay policy is that imposing gender equality in pay, promotions, or dismissals is not actually equitable once we take into account the fact that the underlying ability by gender is different.